Greetings and welcome to the homework problem for Wednesday. This is page 208. If you're understanding, I'm going to do part B to start here. This diagram, while it's in your book, it's always helpful to draw it multiple times for every part. So for B, I'm just going to use what's here. But it also is tricky because these middle parts don't really matter. So I'm going to change my mind and redraw PQRS. It is drawn bad, so you won't have to assume that it's any kind of shape. So just remind yourself of that. We are told PQ is parallel to RS, so I'll put parallel markings, and QR is equal or congruent to PS. That being said, this is all I'm going to mark on there. This center part is for other parts of the problem, so I'm just going to leave the basics here. Now it's asking if I had that information, is that enough to guarantee this is a parallelogram? Well, it's off to a great start. We know and have proven that if the opposite sides were both parallel, it'd be a parallelogram, or if the opposite sides were both equal, they'd be a parallelogram, but we only have part of each. So two things you can think about. I took it and first cut it into a triangle because we had done that in class. And if I were to do that, remember we have these parallel lines, so we should always be looking for either alternate interior or corresponding angles. And these purple lines, there you can see the Z. So when it comes to finding angles, I'm going to go for alternate interior angles. This angle here matches this angle here. Now that's the only one we can do this time because over here, this line is not guaranteed to be parallel with this one here, so we can't actually use those ones. Now, if I were to take away the purple lines, all I have here is an angle. They share this pink side, and then of course they have this other side in common with the double hash marks. So I'm looking at angle, side, side. We all know this is not a shortcut. So this would help me think that this is maybe not possible. And a cool way to think about B is think about another shape of four sides that has opposite sides parallel, one set, and the other opposite sides congruent. And this is a bad drawing, but it's called an isosceles trapezoid. We know a trapezoid has one pair of parallel sides, and these ones could be equal if it was an isosceles trapezoid. That right there is a great counterexample, along with this idea here. I couldn't prove anything else. I was stuck. So this counterexample shows that just because one pair is parallel and the other pair is congruent, it does not guarantee or ensure that it's a parallelogram. So the answer to B here, after all of that, is false.